this problem, we are looking at writing expressions with rational exponents as radical expressions. So what we need to remember is that what we're doing here is we're using, at least in this most simplified version, a to the 1 over n equals the nth root of a. So with this first problem, we have t to the 1/2. So if we look at this relationship over here, a to the 1 over n equals the nth root of a, we have t to the 1 over 2, t to the 1/2. So our n is 2, so that means this simply equals the square root, there's an invisible 2 out here, the square root of t, whatever we're taking to the rational exponent. Similarly with m to the 1/3, again, a to the 1 over n equals the nth root of a, so our n is 3. So that means this is going to be the cube root of m. And then last but not least, problem C, we have r to the 1/4, our n is 4, so that equals the 4th root of r. So we don't really need to check these, but we could check by simply performing the opposite operation of what's being done in the root. So if we have the square root of t squared is t. T to the 1/2 squared, that's also t. In other words, t to the 1/2 squared equals t to the 2 over 2, which equals t. And then similarly, the square root of t squared, that equals t. With these simple examples where we just have a variable being taken to an exponent, it's really not necessary to check, but this is an easy way to check. M to the 1/3 cubed equals m cube root of m cubed equals m. And then the same thing with r, only it's to the 4th power. R to the 1/4 to the 4th power equals r, and the 4th root of r to the 4th power equals r. So simplified, r to the 1/4 equals the 4th root of r, or as a radical expression. They're both technically simplified. M to the 1/3 as a radical expression is the cube root of m, and t to the 1/2 is the square root of t.